are all welcome to today's class. And today we'll be looking at vector differentiation. I believe we've done differentiation during our calculus time. You've done differentiation, integration, we've done that. And this is a senior class, and I believe some of us can still remember some of the differential equations that we've done, the y, the s, partial differentiation. We've done that before now, and we'll be using them in a vector and tensors analysis, and this will cut across different field. For those of us in physics, in engineering, or secretarial stuff, any aspects of this course, these of your discipline, this particular aspect will also touch one or the other. And I want to advise you, please don't just watch, please write. Just write. This is not, remember, I always tell my students, I'm not a CNN newscaster. I'm a mathematician. As a mathematician, the best way for us to introduce ourselves is by our writing, is by solving the problems. And I believe today's class will not be different. So if you have any question at any point in time, please raise up your hands, then I can attend to your question. So once again, my name is Shegun Oke, and I will be coordinating or facilitating this particular course for the rest of the semester. So let me share my screen. So last week we are able to discuss about cross and dot product. And during that time, I gave us an assignment to also look into aspects of cross and dot. Here we did the cross, we find the angle, we find the unit vector, we're able to look for the projection, and here we did the cross product. Then we'll also be applying the cross products techniques as time goes on. But let's move on because of our time. Your exam is very close. So today we'll be looking at vectors differentiation. On vector differentiation, what comes to your mind? You know that, oh, the y, the x. Yes, the y, the x. But for us to get to the y, the x, we still have some definitions we need to also check. So let's look at the definitions here. Here we have ordinary derivative, ordinary derivative of vector, ordinary derivative of vectors. I believe you can see my board.
No, we can't see your board. The screen is blank.
Can you see my board?
Yes, I can see your board.
Okay, if you cannot see,
Yes,
please check your network. Just move to where the network is stable. Of vectors So let's represent this by saying that let R of U be a vector depending on a single line, on a single scalar variable, variable U. Then this is change in R over change in U is equals to R, you remember first principle, plus change in U. Minus R of U, all divided by change in u. So where change in u denotes as increment. That's why we call it change in u. Increment in u. That is, for example, when you have these from origin, start from origin, this line, we call it R of u. Then we have increment from here to this side. This one we said R, U, then we have this joining together, which this one, we call this one changing R. Changing R, which is same thing as R of U plus changing U. And this is R plus U, changing U, minus R of U. So this is just a kind of depicts, but let's look at the R du. In a situation whereby we have ordinary derivative of vector of R of U with respect to the scalar of U is given by the R du, which is the same thing as the limit changing U tends to 0, which is changing R over changing U, which is the same thing as the limit changing U tends to 0. This will be R of U plus changing U minus R of U divided by changing U. If the limit exists, if the limit exists. So if the limit exists, we have this. But what about scalar curve? Let's look at another interesting definitions that would lead us to where we're going. Another definition says space curve. Space curve. So it's talking about if in a particular R of U is the position vector R of U joining the origin, O of a coordinate system and any point X, Y, Z, then our R of U is equals to X of U. Remember, we said the coordinate point is X, Y, Z, and Don't forget our component. Our component is component I, component j, component k. So meaning x ui plus y of uj plus z of uk. So in this case now that we have the specification of the vector function out of u and define it as x, y, and z function of u. Then we can also check if the limit exists at this point by saying if the limit change in u tends to 0, that is change r over change u equals to the r du exist. So at this point, if it exists, we have the r du equals to the x du I plus the y duj plus the z duk. So all these are the formulas that we'll be using in order to solve some of those problems. But let's look at the laws, the formulas, the law that governs the differentiation in this content. Let's look at them. Differentiation. Formula. Some of those formulas will come up in your exams. So if they ask you, they said if A, comma B, and C are differentiable, vectors, are differentiable vector function of a scalar u, and we have this, we call it phi. This is phi, and the phi is a differentiable scalar function of u. Then number one, when you have d du of A plus B, the answer will be the A over du plus the B over du. Please take note. Number two, when you have d du of A dot B, it will be, just watch this one, it will be A dot the B du plus the A over the u dot B. Please, the position is very important. Don't bring B first before A. Take note of that. You will see by the time we started using it, you will see the difference. Number three says d du of A cross B, not A multiplied by B. A cross B is A cross dB du plus the A over dB du cross B. Take note of that. Number 4, when you have d du of phi as a scalar multiplied by vector A, it's the same thing as phi dA du plus the phi du A. Please take notes. All these are not just drama, they are just real. And I want us to be serious about it. All these definitions. Yes, Ajiboye.
All right, sir. Definition number 2, 3, 4. I just want to just ask a question.
Right.
We are trying to express d du a dot b. We say a equal to a dot db over du. I'm expecting plus. There is plus. I'm expecting b to come before dA du. If b come before dA du, is it correct?
No, don't let it come before. That was why I was trying to explain that make sure they did not come. Leave it the way it is.
It's okay, sir.
Yes, because there is a reason for that. That's the law. Let me just put it in a simple term that it is a law. And I will prove one of it for you. Once I prove one of it for you, you will also see why it is like that. I don't know whether I'm communicating, whether you get my point. So on a normal day, this is not a English writing. This is just a mathematics. The way you by the time I explained using first principle to prove it, because in your exam, I've seen it in your exam whereby they ask you to prove that d du a dot b equals to this. Proof. Remember, you guys were doing the paperwork. I will share some questions with you guys after the class. Then you will also take note of that in case they ask you in your TMA and some other stuff you'll be doing. Is that okay? Have I answered your question? Okay. So this will be, you see, we have A dot B cross C in this case. So it's going to be A dot B cross DC. Please, for those of you that means the class of dot and cross, please go and download the video and watch it, plus A dot dB du cross C plus dA over du dot B cross C. Please take note of this definition. It's very important. Number 6.
Sorry to interrupt you, sir.
Go ahead.
Okay. I'm just like you made mention of the cross value. So sorry, I missed the last class, I know, but I hope we don't get confused using cross as multiplication. When
That's why you are in class. You can't get confused. That's why you are here now. That's why you see me mentioning it, right, as a cross.
Yes, sir.
Nobody will read what you are saying. And nobody will mark what you are saying, but they will mark what you put down, right?
Yes.
This is not oral exam, it's a written exam, whereby since you're in class, you know the meaning of cross, you know the meaning of dots, and you know the principle guided them. Please take note of that. The principle behind them. That is what you need to master. whether cross or multiplication, all you need to do is what's the principle behind the cross and what is the principle behind the dots. So let's go at it. Have I answered
All right.
you?
Yes, it's fine, sir. Thanks, sir.
You're welcome, sir. So anybody that, some people that did not come to class, now when they see this one, they say, oh, B multiplied by A. And meanwhile, it's not the one. So it's a cross that the text is talking about. Because of space, that's why I'm writing it this way. You can write it straight. Okay. Let's me quickly solve A du dt, d du the A dot B. I will do that. Then I will also do the cross, one of the cross, so that you guys will also have idea before we move on to the next topic. So let's look at the example. The question says, prove that, is that if A, let's write question 1, if A and B are differentiable, function, of a scalar u, then prove A d du of A dot B equals to A dot dB over du plus dA du dot B. Then B, d du A cross B is equals to A cross the B du plus the A du cross B. So take note of that. That's the question that you were given. So how do we solve this problem? Now lies in your hands. So let's move on and solve this one. It's pretty simple. All you need to do is to follow the principle behind this. Remember, I gave us the definition here. Sorry, I gave us the definition here. Look at this definition. I gave us the definition here. Let me just change. So we have this definition. Please circle it in your notes because we'll be using the definitions to prove the problem we have. So now let's look at it. So for us to solve this problem, we have the solution for A will be d du A dot B will be equals to the limit changing u tends to 0. Right. How do we define A? A will be A plus change in A. Remember, we did with R the other time, but this is A. A plus change in A. Let me change the marker first. Let me change the marker so that you get what I'm saying. A plus change in A dot B plus change in B minus A dot B. Everything divided by change in W. Change in U rather, sorry. So we can now distribute. Distribute means open the bracket, right? So let's distribute our bracket from here to here. So how do we distribute it? So it's going to be A let's write the limit first. Our limits change in U tends to 0. So we have A dot B, right? That is, what I'm doing now is take this one to multiply this, then take the same one to multiply this, then take this one to multiply this, take this one to multiply this. So let's look at it. So we have A dot B plus what? A dot change in B. Then we pick B, change in A. So we have it to be plus change in A dot B, then plus change in A dot change in B. Everything minus A dot B, all divided by change in U. Don't forget, this will go with this. Do you agree with me? Are we together?
Yes, sir.
Yes, sir, we are together.
Okay, good. So if those two cancelled, it remain limits change in U tends to 0. So we have A dot change in B plus change in A dot B plus change in A dot change in B divided by change in U. So what we need to do now is we will now divide each of them by changing U with the hope that we still have our limit, right? So let's look at it. It's going to be the limit change in U tends to 0. So we have it to be, the first one will be A dot change in B over change in U plus change in A over change in U dot B, right? Plus change in A over change in U dot change in B. That is what we have. Don't forget, we all know that our change in A, change in B, they are all, we have the same things to them. What is the definition of change in R? The one we did earlier on. Let's check the definition here. Look at the definition here. The definition means the R, the U, if the limit exists. Please, am I communicating? I need a confirmation for you guys.
Yes,
Yeah.
Your Excellency.
Okay, good. So at the end of the day, you discover that in this case now, who can tell us the solution to this answer? From here. Should I call name?
Let me guess. It has been long. But if change U tends to 0, that means that we are going to divide through by 0, which might automatically give us 0. I'm not sure.
No. So you are missing it up. Go up to the definition. We work with the definition now. So changing U, this U can be any value. Don't forget, it can be any value. Are you getting the point now? But if we say changing U, we can say U tends to 0. So we are not saying you should substitute 0 now. Mathematically, it will not work. So therefore, what it simply means is this. I know that changing B over changing U is talking about differentiation of B. So it simply means I have what it takes. This place now, this place will be A dot dB du, that is the meaning, plus the A du dot B. But what happened to this place? Remember, this is the only one that is remaining here. This tends to 0 at this point. Are you following the point now? Hello?
Yes, Your Excellency.
Okay. So at the end of the day, we are having this. So you can see the definition that I gave you earlier on. Look at the position of dot B in this case. And look at it. Look at this one. So if you want to write your own and you put your B here, then you missed it. According to the proof we did now, look at
That
where
was why you were saying it needs to follow the rule.
you need to follow the rules. Look at the rule that I just proved one of it for you now. So please take note of that. Any question? Okay, let's move on. There are many ways of solving this problem. You can also use IJK, the one we used last time. If you use IJK to multiply them, if you watch the video of dot and cross products, you can use this one. You can use it to solve this problem too. But to cut the long story short, for the IJK, if I want to use IJK, okay, let me use IJK too, or let's use this one. If I said d du of A dot B, I want to use dots now. For dots, we now said, for dots, in this case, we said, let A equals to A1 A1ji plus A2j plus A3k. Then B is equals to B1I plus B2j plus B3k. So we have this. Then the question is du of A dot B. What is A dot B? A dot B, it simply means this dot this. Remember the last time when we did this, we said, I gave us the quote that says I dot I equals to J dot J equals to K dot K. Is equal to what? Anybody?
Equal to 1.
Is equals to 1. Is equals to 1. Any other combination will be 0. Please take note. Any other combination will be 0. So that is why we said A1, B1, that is, I have A1, B1, sorry, B1, I dot I, right? Plus A2, B2, J dot J, plus A3, B3, K dot K. That is the meaning. And our A dot B will equals to A1, B1 plus A2, B2 plus A3, B3. So if you have this, then substitute everything into your differential. That means D of A1, B1 plus A2, B2 plus A3, B3 du. So what will be the solution for this? The solution for this will be, the definition we are talking about is, I will hold all my A constants, then I will differentiate B, meaning A1 dB1 du plus A2 dB2 du plus A3 dB3 du plus, because I know the definition of dots, so I know the definition of multiplication too, plus will be the A1 du B1 plus the A2 du B2 plus the A3 du B3. Therefore, I have the first one will be A dot the B du plus B plus the A du dot what? B. So that is the solution for this. Any question, please?
Ah,
So we've tried the two methods to see how we can easily solve them. So let's look at the B. The question
Sorry,
B
I'll
is
ask the question. Sorry.
yes, what's the question?
Sorry, I forgot the exam purpose. Is it possible a question come in the sense that you specify how you want the student to solve the question, or either method can be used?
So that's a good question. Either method can be used, but however, our advice when you are solving differential, just use the first method.
Okay, sir.
Remember, I'm not the one that will mark your book.
Of course.
So I'm just facilitating and to tell you exactly what it is there for us to mark and the standard. I'm just giving you the standard of how you should solve a problem.
Okay.
And I believe the marking scheme will cover the two phases anyway.
Okay. Thanks, sir.
You're welcome, sir. So we have limits. U tends to 0. We are solving B now, meaning U tends to 0. Then we have A plus change in A cross B plus change in B minus A cross B, everything divided by change in U. I've explained this one, and I believe it's the same. We should be able to solve the same thing by saying limits change of U tends to 0, A cross change in B plus change in A cross B plus change in A cross change in B. I believe I've jumped one step because A cross B has already canceled each other. Yes or no? Hello? Silence means yes. So in this case, we have A cross change in B over change in U plus change in A over change in U cross B plus change in A over change in U cross change in B. At the end of the day, the final answer will be A cross the B, the U plus the A, the U cross B. Any question? So the alternative method for cross, I will use this one also to solve it. It's, or we can use this method. Let's say d du of A cross B is the same thing as d du of I j k. This is A1, A2, A3, B1, B2, B3. Right. So for the last class, when we talk about the cross, what do we mean by cross in this case? It's just like we have plus, minus, plus for matrices. So of taking, let's say I'm taking this one, high. If I'm taking the I, which is, this is, like I explained, this is row 1, row 2, and row 3. This is column 1, column 2, and column 3. Take note of that. So, because of d du, we have to bring d du enter now, so that we can use a theorem of differentiation of determinant to become this. So if you're using this, so it's going to be I, J, K. Let's say we keep A constant, A1, A2, A3. But we differentiate B. The B1 du, the B2 du, the B3 du, plus I, J, K. We differentiate the A1 du, this is B1. The A2 du, the A3 du, so it is pretty simple. All we need to do is find the determinants of each of them, and this becomes the solution of what we are looking for. That is, if I find this first one, therefore, the first one is talking about A of this, and this one talking about the A of B. So if you want to solve this one in a normal way that you want to write, you have a figure, of which we'll soon go to where we have a figure. How do we solve it when you have something similar like this? How do we solve it? I. Let's just say I. We pick the I, which is the first component. Remember, plus, minus, plus. So if I pick I, it simply means that where the I belongs to will be parallelized, and the column will parallelize, the row will also parallelize. It remains what? This will multiply this, and this will multiply this, minus this. So A2 the B du minus A3 the B2 du. That is what I will have. Then I do the same thing. The next value, I will release the first one, the column 1, and release this one, release this one. Then the column 2 will also parallelize, and row 1 will still maintain the status. But J is negative. J is negative. You put the negative there. Then you pick it up. If I pick it up, what do I have here? Meaning I will have A1 multiplied by the B3 du minus A3 multiplied by the B1 du. So the last one will be, I will release this one, and I'll pick this one. So it will remain positive K, which is A1 the B2 du minus A2 the B1 du. So this is what how we have for the first phase. I will do the same thing to the second phase. But in this, all these contents is saying that from here, we already get our solution anyway. From this place. From this place. Our answer is, using the theorem on differentiation, we have this to call the solution. We have A cross the B, the U, plus the A, the U, plus B. So this is the answer for this. So what am I trying to explain here is, I'm just explaining the way you will solve it with this one is just how you will solve it when you have a real problem. So in this case now, look at it. When I say A cross this place now, when I look at this place, sorry. Look at this place. Now, when I say A cross, you see that we have A1, A2, A3. They all belongs to A. We just splitted them. A1, A2, A3. That is representation of component 1, component I, J, K. So anytime you see the B1, the B2, the B3, they are still talking about the B. So take note of that. But look at this definition too. It said the A1, the A2, the A3, they are still talking about the A. The A, the U cross by B. So let's take note of that. So this is very straightforward question. But when you have a problem, you'll be able to relate with the problem. I'll give us one of the problem now before we call it a day. Any question, please? Okay, let's move on. Look at this solution. Look at this problem. Question 2 says, if A equals to 5t squared I plus tj minus t cubed k. And I said B equals to sine ti minus cos tj. The question says, find A d dt of A dot B, B d dt of A cross B. You can also find this. D dt of A dot A. Okay, it's pretty simple. I believe we can solve it without stress. So let's look at A dot B. Are we there, please? Can you hear me?
Yes, sir.
Yes.
Okay. So let's look at the solution. A dot B. We know A. First of all, let's say A dot B is equals to what? What is A? 5t squared I plus tj minus t cubed k dot our B. Our B is sine t I minus cos tj. Minus cos tj. Okay, so what we need to do is we can first of all find the solution for this. If you want to do it that way, there are two ways of solving it. Or the first thing is, okay, let's do the one of togetherness first. A dot, remember, this way, if you want to solve this, it's going to be I dot I. Don't forget. So I dot I will be what? Who can tell us? We have 5t squared multiplied by this will be what? Sine t. Plus. But in this case now, minus is the other side. You don't do it as if you are opening the bracket. You only say I dot I, j dot j, then k dot k in case you have k. K in this case is 0, so you don't have k. Are we together? So we have, this one will be negative. Will be minus t cos t. The rest will be 0. This is equals to a dot b. Now, but for us to solve the problem, remember we had to do a d du of a dot b. What is the definition of d du a dot b? Is the same thing as a dot db dt plus what? dA over dt dot b. Am I right? I need a response, please.
You are right, sir.
Is the formula the same thing in your own? So
Yeah.
what you need to do now is, we are still coming back to this one, but I'm just trying to give us different ways of solving this problem. Remember, we have our A. Our A, what is the A dt now? Let's solve this one first. Let's look for the A dt. How do we differentiate A with respect to t? Differentiation. The A dt, anybody? This is your A, differentiate your A with respect to t. Do you still remember how to differentiate, or do I need to remind us?
That should be 10 cos t.
You said what?
Cos.
I'm
That
only
should be
telling you
10t.
10t,
Then the sign will
Cos t.
change to cos.
No. I'm not, we are not differentiating the A alone. A alone.
Okay.
The
Okay,
A dt.
alone.
The A dt will be 10t, right?
Yes, sir.
I. Then if you differentiate t, what do you have? 1. It returns to j. If you now differentiate, some people don't understand how to differentiate. Okay, let's start from here. On our differentiation, let's say you have your y. Let's say y equals to x raised to power n. We are just trying to revise differentiation. Recall that when I recall, we're just a kind of digress now. Let's y equals to s raised to power n. The y, the x is equals to what? That is, you bring this n down dot xn minus 1. That is how to differentiate. N will come down, then you now take 1 out of it, which is simply means nxn minus 1. That's it. If it is integration, it will divide and increase. So in this case now, please remember, then when you now want to say the a, the t, the a, the t, we know our a to be 5a is equals to 5t squared I minus what? Plus tj
K minus T cube K.
minus t cube k. So differentiate a now, you have it to be what? 2 multiplied by 5 will give you 10t I.
T.
If you differentiate
Yeah.
if you differentiate t, you get 1 plus 1 multiplied
J.
by j. Differentiate this, you have minus 3t
3
squared
K.
k. Good. So let's do the same thing to b. Our b is equals to sine t I minus cos t j plus 0k, so that you know there is a 0. The b, the t will be what? When you differentiate sine, what do you have? You have cos t I. Then when you differentiate cos, you have minus sine. Minus sine tj. There's nothing here. We have cos ti plus sine tj. So this is what we have. Now that we know this, we know the A, we know the B, it is easier for us to solve the problem, because the formula says d dt of A dot B is equals to A the formula is what? A dot the B dt plus the A dt dot B. I know my A, I know my dB now. My A will be what? What's my A? My A is 5t squared I plus tj plus or minus t cube. Dot, what is the B? The B is there up, cos ti plus sine tj plus 0k. Then plus, what is the A? 10ti plus j minus 3t squared k. Dot, what is B? Sine tji, sorry, minus cos t j plus 0k. So we can now, yes, Bolaji.
Yes, sir. I was expecting the B, the T to be the differentiated form of the B
Yes.
and not the main B.
So the B, the T, you are to differentiate B, right? This is our B.
Yes.
This is the
Yeah,
B.
but sir, we are still bringing the B. We are still bringing B instead of the B, the T.
Where? You mean at this point?
Yes.
No. This is the normal B. Look at it. This is minus.
Okay.
Are you okay with that?
Noted, sir.
And this is sine, this is cos.
Yes.
Uh-huh.
Said it. Thanks.
You're welcome. So all you need to do now is dot with dots. That is dot with components. The first one will be what? Five t squared dot cos t. Do you agree with me? Then j to j will be plus t sine t. Then there's nothing there, which is 0. Any question? Then plus 10t sine t minus cos t. Everything will be what? This is the, then you can write it in a neat way. We have cos here. We have cos here. We can merge it together by saying 5t squared minus 1. Cos t is common. Take it out. And here plus 1t, t sine t plus 10 sine t will give you 11t sine t. That's the final answer. Any question? Now, somebody should ask, what happened to the first one we did? This one. Do you know you can also get your answer from here direct? How many of us know that? But I'm not sure whether you have the same mark with someone that did this. So let's take note of that. Because if you want to have your final answer from here, all you need to do is just to differentiate this one. But you will use product rule to differentiate it. You first of all differentiate one, old one constant, differentiate another one, and that settles. Because they are both as function of t. So that is where the problem lies. If you don't know how to differentiate such, please don't try it. Any question? So I can ask you to go and solve the cross now. Can we do this one by ourselves? Please, I need a response. Hello?
Can try. You
Can we
try,
do
sir.
it, or you want me to do it? Silence means we can do it.
Do it, sir.
We don't mind if you help us do it, too, sir.
Okay. So we know the solution for the one we started with. So this one says for B, we have d dt of A cross B, which is the same thing as so the same thing as A cross the B over the t plus the a over the a, the t cross b. We know a, the way we did it the other time, is the same thing as I, j, k. Remember the a will be what? 5t squared t and minus t cubed. Don't forget the negative. This first one will be cos t sine t 0 plus I j k. This one will be, we know the differentiation of, we've differentiated the a dt. All you need to do is just to extract those differentiation we have up there. Just put it there, 10t. This is 1. This is negative 3t squared. Remember the differentiation we did the other time. Look at it. This is what I'm using now. And this one. I'm using them. Then we have sine t minus cos t and 0. So all you need to do is just a kind of expansion, which is very simple. The way we did it the other time, plus, minus, plus. So taking the first component, let's say I is our first component. So if I pick I, everything here will paralyze, followed by this. It will remain this multiplied by this. It will remain 0 minus t cubed sine t. That is my I. Then I'll do the second one for this. I'll release this one and pick this one now. It will be minus j, right? If it is minus j, I will have 5t squared multiplied by 0 minus what, please? Cos t. Then, what do we need again? Then we do this, the last one. So we have the last one to be plus k. Our k will be what? 5t squared sine t minus t cos t. So that is the first phase. You can harmonize this one before we solve the second matrix. We can harmonize this one by saying minus times minus plus. So I have what? I have t cubed sine t I. This is 0. Minus times minus. Aha. So this is why you have to be careful. Minus times minus. Plus within. But there's
Plus.
another negative which returns to minus. Minus what? T cubed cos t j plus, you can leave this one in brackets the way it is, 5t squared sine t minus t cos t. Okay, so remember that is first matrix. So you do the second matrix the same way. If I want to do the second matrix now, remember it's going to be plus this one. So let's look at the second matrix. We have this one. We pick I. Don't forget the same way. Plus, minus, plus. So this place we paralyze. It will remain what? It will remain for me to be I into 0 minus 3/2 squared cos t. Because minus times minus will be plus, and I have minus within. So it's like this. So minus j now. We want to do the j. I will cancel the second column, a first column, cancel the second column. So it's going to be 10t multiplied by 0. 0 minus times minus, positive. 3t squared sine t plus k. The one of k. The one of k will be a big, this one cancelled. You pick this one, right? So you have this multiplied by this. So I think our k can go by 10t, k, negative 10t cos t minus sine t. Let's see. Yes, minus sine t. 1 multiplied by sine will be sine. So you have this one. So in this case now, we can harmonize this one to and add it together with the other one. So this will be what? Minus 3t squared cos t I. This is 0 minus 3t squared sine tj. Then we can factorize minus out or leave it the way it is, plus just leave it the way it is.
But sir,
Go ahead.
this minus 3t, this minus there, I think it should be plus.
Which of them?
Because from the match, the first minus.
This one. This 3t.
Yes, this minus 3 cos t.
Okay, let's look at it. This is the matrix, right?
Yes, sir.
Let's do it this way. This is the first one, right? This multiplied by this is 0. We put 0 down. Is 0 minus, that is normal thing. Then you have 3 cos t squared multiplied by negative cos t will be positive.
Yes.
Do you agree with me? Hello?
3, sir?
So
I don't get it.
So 1 multiplied by 0 is 0, right?
Confirm. Yes, sir.
Minus negative cos 3t, negative cos t multiplied by negative 3t squared. You have 3t squared. You have positive 3t squared, right?
Positive. Yeah, exactly,
So
sir.
positive times negative will give you negative. Yes, because positive, the two of them, they are positive. They are negative, negative. They cancel each other. But originally,
yes.
There is a negative there is waiting for them. And unfortunately,
Okay.
none of them is negative. They are both,
Okay. Yes.
they are positive. That's why you see that one.
Okay. Yes, sir.
Is it okay?
Yes. Yes, sir. Yes, sir. Thank you, sir.
You're welcome. So this is what we have for K2. So All we need to do now is how do we merge all the components together? Remember, those components, this is matrix A, matrix 1, and this is matrix 2. Merge it together. Add it together, you have it to be, let me use the red pen here. So it's going to be I plus I. So this is negative, this is positive. So we have it to be, all our I will be t cubed sine t minus 3t squared cos t all I. Don't forget, this is not dot dot, this is just addition. So we just factor the I out. Then this is what I'm doing, this and this together. So the second one will be plus, let's say plus for now, because we don't know whether it's still going to turn to minus. You have j. So we have minus t cubed cos t minus 3t squared sine t, or j. The j here is negative, so I can factor negative out, but I'm coming to that. Let's do the one of k. The one of k is very smooth. We have sine, so let's add it together. It's going to be, our k will be 5t squared sine t minus sine t. Then we have here t cos t and minus 10 cos t, which making 11, negative 11t cos t, all with k. So we have the final answer to be these, or we can have your final answer to be, it's very simple. Factorize the negative out in the j. Everything will be t minus 3t squared cos t I minus t cubed cos t plus 3t squared sine t j. Sorry, there's a plus here, don't forget. Plus k 5t squared sine t minus sine t. You can't say you add this one together because this is 5t squared. Assuming this one also have t squared, that's why you can add it together. Please take note of that. Minus 11t cos t. Any question? Wow. Any question, please? Does it make sense to you? Does it make sense? Any question? May I stop sharing?
It's fine, sir. It's fine, sir.
Okay. Okay, guys. Any question to us?